So again, I'll just grab some numbers from a student's problem. Because again, these numbers are variables, right? We've got 0.117 grams of zinc, and that reacts with 51.4 milliliters of HCl. And the key here is they tell us that the zinc reacts completely. And this is an aqueous HCl solution. So there's two keys to this problem. They tell us the zinc reacts completely, and they tell us that this solution has the properties of water. It's got a density of 1 gram per milliliter, and it has a specific heat of water, 4.184 joules, right, per gram degrees Celsius. So it's HCl solution, but it's an aqueous HCl solution. So even though HCl is there, it's there in water. So that's where we can use the density of water. We can use the specific heat of water to say, okay, I've got a 51.4 gram solution of HCl. And that HCl solution, right, it goes from 23.4 degrees Celsius, and it goes all the way up to 24.6 degrees Celsius. So we're going to start with this HCl solution and then use that to figure out more about the zinc. So Q for the HCl, right? This aqueous HCl, I got 51.4 grams. The specific heat of water is 4.184 joules gram degrees Celsius. My delta T, right, is 1.2 degrees Celsius. I went from 23.4 to 24.6. Multiply those all together, right? Q for the HCl equals 51.4 times 4.184 times 1.2, right? I get something like 258.069 joules of energy. So what does that tell us for the heat of the reaction? Yeah, right? The reaction lost 258 joules of energy, right? We just flipped that sign. All right, now that we've got the heat for the reaction, they want to know the heat of the reaction in joules per mole. So how do we go about finding moles or joules per mole? Yeah, we need to find moles of zinc, right? So that was part one. Part two, now we use the moles, or now we use the mass of zinc. I've got 0.117 grams of zinc. We go to the periodic table, right? Zinc is 65.38 grams per 1 mole for the zinc. So let's just convert grams of zinc into moles of zinc. We get 1.789 times 10 to the minus 3 moles of zinc. And then, yeah, we want joules per mole. So I literally just take that energy, right? I release 258 joules when I had 1.789 times 10 to the 3 moles of zinc in the reaction. So we divide those two, and it's going to give us units of joules per mole. We divide those two, and I get something like 1.44, a negative 1.44 e to the 5 joules per mole for that energy. If we take a look at significant figures, I would go with 3 significant figures because the mass of zinc, the volume of HCl is 3 sig figs. So all those being 3 significant figures, I would say question 44 should have three significant figures in the answer. Yeah. Yeah. Do we have